Above into Rama Principal Solutions Architect, specializing in generative AI with AWS. And today, I'm super excited to walk you guys through a module that I wrote, where I'm gonna walk you through how to fine-tune a Mistral model on AWS. In this demo, you're gonna learn how to use a Hugging Face model that has been created with Mistral and fine-tuning in an insurance data set, and you're going to learn how to port this into one of the AWS accelerators architecture using Neuron, so you can deploy your model on top of inference. So the first step is that you need to import the libraries, right? As I'm going to do right now. That's the very first step. Then you're going to learn. The second step is to export the important variables, which is going to be used throughout this demo, where you need to specify the model ID, batch size, sequence length, max token, and so on and so forth, number of cores. Just for the sake of easy, everything has been set up to you. So this is the model we are going to be using from Hugging Face, the batch size, and all the parameters required to compile this model. Remember, if you wanted to run a model compilation from scratch again using the optional CLI, which is an optional step, by the way, you're going to need to create a new machine following these steps, and also you're going to need to set up your Hugging Face token. But for now, I'm going to just run this step that you must have finished so far. Then I'm going to skip section 3, as the model has been compiled and made available to you at the Hugging Face. And the next step we're going to do basically is to deploy model to SageMaker endpoint. So we're gonna use all the parameters that are well documented in this Jupyter notebook, and this is the first Jupyter notebook cell we're gonna run. Now you should be ready to deploy the model in a SageMaker instance. And here you can see the model is being created. It's going to take like a few minutes, and once this is finished, then we should be able to test our model deployed on top of a SageMaker endpoint. As you can see now, our Mistral model has been successfully deployed into a SageMaker instance, an endpoint. And the next step is to test the SageMaker endpoint with both the Hugging Faces and SageMaker's APIs. For this, what I'm going to do is that I'm going to run this cell, which has a create sample request using the predictor API, Hugging Face API, and you're going to see this sample queries being sent to the SageMaker endpoint, and we're going to get the response from the model. As you can see here, we're going to see several steps like request 1, where the question is, what benefits do I get with my current health plan? And you can see the answer, sample request 2, 3, and 4, and so on and so forth. And once this is done, we can skip to the next step, which is to send a sample request to the model, but this time using the SageMaker API instead. And once this Jupyter notebook cell is finished, what we can do is to run the next one, which is pretty much the same, but now using the SageMaker API, using the invoke endpoint. That's going to be a synchronous call. For this one, we're going to just run this cell, and you're going to see the model response below. So the question is, how can I reduce my monthly insurance premium? And here is the answer. Really straightforward. And now a very important step, which is section 6, where we're going to be converting this model, which has been created using PyTorch, so that in the next step we can import this fine-tuned model on top of Bedrock. So this is a very straightforward step, and safe tensors is a lightweight and efficient file format designed for securely storing large model weights. You have all the instructions here, but just to go straight to the execution, we are going to run this cell where we're going to be converting this model. Remember, if you wanted to do this from scratch, you're going to need to have a host which has at least 120 gigabytes of memory, so you can properly load the model and convert to this format. So let's execute this. And again, this should take like a few minutes to complete. And once this is completed, we're gonna move forward with the next section, which is section 7. You see below, the conversion has been successfully completed. And now we are ready to move to the next step, which is uploading the converted model to S3, so that we can start a Bedrock job to import this model. So basically, section 7 is really straightforward, and it's where I'm gonna upload into an S3 bucket. And here are all the steps, and I'm gonna run this. So it's going to take like a few minutes again, because we have a couple of large files and we have 21 files to be uploaded. You can realize this step has been successfully completed. All the safe tensors files has been uploaded into an S3 bucket, and now we are ready to start importing the model into Amazon Bedrock. But before we can start with this job, we're going to need to create an IAM execution role for Bedrock with all the parameters required to start a model import job. And in section 8, we do that, and now we are ready to start with section 9, where we're going to create and submit a model import job to Amazon Bedrock. So in this step, we're going to be using the create model job import job API, which is really straightforward. And the model has been created, and now we are going to monitor the Bedrock model import job status. And here we can see every 30 seconds we check to see if the model is successfully imported and available to be consumed. Again, this is going to take like a few minutes, and once we are ready, we should be able to call the imported model using the Amazon Bedrock API, which is what we're going to do in the section 11. Now that we successfully imported the model into Bedrock, as you can realize based on this message, we should be able to call the imported model using the Amazon Bedrock API. So the first step is that I'm gonna set up the client and use the Converse API to send a question to the model. Sometimes even when the model is successfully imported into Bedrock, it takes a few minutes to be made available to Bedrock. Don't worry about it because I have implemented a retry process in case there is an issue when invoking the message the very first time. And basically that's what we're gonna do now. I have set up like up to 10 attempts to call the model to make sure it's gonna be 100% and fully available to be consumed by clients. After the third attempt, we successfully call the recently imported model using the Converse API. And now that everything is set up, we are ready to call the model using the Converse Streaming API. I'm going to scroll down, just import the client, and here we go. We can see all the questions being asked, number of input tokens, output tokens, total tokens, the latency in milliseconds, and I'm asking multiple different questions. So for example, this one, sample number 3 says, are dental treatments covered in my current insurance plan? And here is the answer. And for example, with sample 5, can you explain what deductible means in my policy? And here is the answer. A deductible is the amount you are required to pay out of the pocket before your insurance coverage begins. And all the details related to that response. And last but not least, we're gonna run a Streamlit application that we created to test the same model on top of both sources, right? And basically what we need to do is to create a app config JSON file, which is going to be based on all the configuration we have been creating throughout this Jupyter notebook. So I'm gonna basically run this command. It's going to populate the app config JSON file, and then basically I can run the application by simply copying this command and going to the terminal and then running this command. And now that the application is up and running, we basically need to open a new browser tab and call this application. And this is the interface. So basically I have the option to select the model from SageMaker or Bedrock, and you have a couple of pre-populated questions, but you are free to ask whatever question you need. But in this case, I'm gonna use the ones that are available already. So I'm gonna pick, for example, how do I file a claim for a recent doctor visit using SageMaker? And here is the answer, the response from the model. And I can ask the same question to Bedrock, and we're gonna see the stream from that call. So for SageMaker, we are performing a synchronous call, whereas with Bedrock we are implementing an asynchronous call. But we are able to do both modes with these different models using either SageMaker or Bedrock. I'm gonna pick a different question and ask, tell me about insurance and its risks. And here is the answer. And I can ask the same question to SageMaker. And here is the answer in asynchronous mode. Or instead, if you prefer, you can use the Amazon Bedrock console to test the recent model we just imported. And this is really easy and it's straightforward. You basically need to go to the playground, click on the select model button in the same way as you'll be doing if you wanted to test with one of the default model providers such as Anthropic, Mistral AI, and so on and so forth. But this time you need to pick imported models, select the model we just created, click on apply, and then provide a prompt. And this is a question I'm going to ask. Tell me about insurance and its risks. And here is the answer. This is another way you can test the recent imported model. So that's all I wanted to share and to show. Hopefully you guys have enjoyed and see you in the next session. Thank you. Bye.